No, Arla sir. Yeah,
Yes.
just come.
That's right, sir.
வந்துச்சு again போயிடுச்சு.
Yes, sir. Just a minute, sir.
Okay.
To see now, sir.
Yes, sir. You proceed.
Okay.
You go to full screen mode. Yeah.
Yes, it's full screen mode, sir. So I hope all of you are seeing this. So today's topic is green electronics and what is the importance of green electronics. We'll see one by one. So I will start with this basics like what is electronics. I will not go deep into electronics or what subject is like that, and merits, what is actually a green electronics, why we are going to it, and a few basics. So with this available time. So what we know about basically when we talk about electronics, okay, any people will tell, okay, radio is electronics, TV, computers, etc. But the fundamentals as a engineers or even a physics persons, we must know what is this electronics. It is science which is concerned about design of circuits with the help of transistors, microchips, resistors, capacitors, etc. And also it is the study and behavior of how these electrons and other particles are involved in semiconductors, conductor, vacuum, or gases. So based upon these studies only, so many devices, starting from the very device, the diode, the PN junction diode, transistors, bipolar junction transistors, field effect transistors, like that, it emerged. And thereafter we launched integrated circuits somewhere around 1950s. And then came this microprocessors, microcontrollers. The sizes were very big. As the technology improved, we tell a term called scaling. The size of the transistors got decreased and the number of transistors within a small area has increased. So with this advent, so many technologies side by side has evolved, and we have got a lot of electronics products. And many multinational companies, they set up new fabrication units in their respective countries. Unfortunately, in India, we have one or two IC fabrication units only. And we have got lakhs and lakhs of ICs. So with as the years rolled, the sizes of the transistors, because why I'm saying this transistors, because they are the main in any ICs or any memory chip, whatever the pen drive that we are using. So the sizes of these transistors, especially we called metal oxide semiconductor field effect transistors, their sizes got reduced. And so many applications oriented devices has been manufactured. So the technology improved, we have got electronics or electrical or hybrid. So with this 21st centuries, we have got so many electronic devices fighting our toys. So we are talking with this smartphones, computers. We might have seen in our offices whatever the devices some 10 years back. Now you can see how it has changed. What is the memory capacities? What is the speed at which it is operating? We all talk about, okay, it is i5 system, i7 system, i10 system, 10th generations, how it has evolved. So that's the rapid success of the only computers, the hard disk, memory cards, our smartphones. We have seen a lot of changes in our smartphones. Earlier, it was a normal phone. We don't have any touch phones. Thereafter, touch phone came. A lot of features are added. There are certain people used to have cameras with the film rolls. Now you cannot see any cameras with the film rolls. So all things has come in our phone. People do have digital cameras with the charged couple devices. Again, it is also an electronic product. In our home appliances, starting from refrigerators, microwave ovens, iPods, air conditioners, all of them are having electronics part. So there is no part without electronics. So we are living happily, comfortably. It's okay. But what happens when all these are done, when anything goes wrong? Okay, it is useless. We have used it for 5 years, 10 years. We have to throw it out. We have to give it. So all gets dumped at one place or another places. That is the backside or underside of this electronics. We are enjoying the privileges of electronics, but there is a dark side in electronics. So you can see in this class, I have just, it's the beginning, I have just taken some 4 elements which are present in the electronics boards. It are very harmful. Especially the very first one which you can see, lead. It is the one of the most and largely used element in electronics, especially for soldering. Cadmium, mercury, etc. This PBE, polybrominated etc. So all these are helpful in doing, but the dark side is they are very harmful to the environment and they are very toxic. So we will be seeing some more elements in the further slides also. So I don't want to go a lot about this electronics. We have seen a lot of technology improvements and how we are using it. But the main concern is when we are used it, when the lifespan, any of the electronic devices or electric devices, maybe any computers, a monitor or a CPUs, a keyboard, mouse, or it may be any pagers, any smartphone, mobile phones, our refrigerators, our washing machines. So all these things has got a lifespan. Once if it, what you have to do, we have to throw it or we have to keep dump. So this is the waste. We call it as electronic waste generations. When we talk about electronic waste, it is not only computers or computer related things. All the cells which contain electronic parts, even this electrical oriented studies also, we can bring it under e-waste. And this picture, you can see, just for this need, you can see all these electronics parts. You can see a lot of printed circuit boards, we can call it PCBs. So all are dumped at one places. Okay, we are collecting it. We collect it or someone's going to collect it, we are going to put it, and they are dumped at some places. So what we are going to do with it? How we are going to manage it? We can see here a lot of monitors, CRT monitors. Now you cannot see anywhere in CRT monitors. Hardly you will see. All we are seeing LED or LCD monitors. Now what about this CRT monitors? Not only this monitors, our CPUs, the cables which is associated with them. So instead of cable, we have copper. So what we are going to with that? So this is an alarming situation, since every minute, every seconds, we are getting lots and lots of waste like this. And as I told earlier, the same thing which I'm just repeating with the slides, like electronic waste from our home, any like DVD, VCR player, CD players, etc. And this percentage may vary from country to country. Then computer, telephones, faxes, printers, etc. Televisions, monitors. Nowadays, you can see we are not using, you will not find even in any home the old model televisions, CRT televisions, all are LCD, LED, OLD. And what about the lifespan of those television sets? Even when you are buying it, the person, the salesman itself will tell, sir, this will work for only 2 years or 3 years or 1 year. That's all. That is what lifespan. Imagine, think about the earlier radio set, which we had earlier, some 15 years back. We will be using it for 10 years, 15 years. Even in some their houses, they use the radio sets which are 30 years, 40 years old. And here in the electric weight side, as I told earlier, refrigerators and the modern days refrigerators has got plenty of electronic parts involved in that. And there are many sensors in it. All sensors are electrical sensors, electrical and electronic sensors. And we are having new technologies, Internet of Things. So washing machines, air conditioners, vacuum cleaners, all of them do have electronics part in that. Any printed circuit boards, so many ICs are there. So all of them, you take it, you dump it at one place, whether in our home or in any graveyard. So that is electronic waste, e-waste. So this is actually a statistical information given by United Nations University. You can see in the y-axis, it is in million metric tons. In the year 2019, it is around 53.6 million metric tons. So as the year progresses, right now we are in the end of 2022, okay, around 60 million metric tons. So every year it is increasing. This is a proposed statistics up to 2030. So 74.7 million metric tons of electronic waste will be gathered. So how much of metric tons, not even we are going to use any of our household cooking, those are degradable waste. This e-waste tons are more than the other wastes. So it is alarming situations. Normally, these are the three ways by which this e-waste are disposed. The first one is incineration, second one is landfilling, third one is recycling. Maybe some of them are interlinked. A small glimpse of each of these disposable methods, I will tell you. Incinerations, basically incineration is burning. We might have seen even in our home when there is a lot of waste material, people will just burn it. Even the scavengers or municipal persons, when they come, they will take something, the others they will burn it. So incineration is same thing. We are burning, you can see a picture, we are burning, keyboard is burnt. So it is going to become ash, so that it is going, the space is reduced. So incineration is actually, it is a burning of materials so that we get ashes. But what is the downside? So many toxic materials are there. So they also get burnt. It will give rise to air pollution, water pollution, etc. Recycling also, we want to take some materials, we have to take some material. So plenty of yes, is Engg 3 word, and it gives a lot of, so there are so many diseases, health diseases. Incineration is dangerous. We should not actually do. Even we should not allow our generations even to burn paper or unwanted materials or plastics. There is no awareness. So the second disposable, mostly used, landfilling. Landfilling is just we are throwing out in some places garbages. So we put some waste somewhere, okay, go to a remote place, out of a city or out of a town, just put it there and come. So municipal corporation or municipality persons, they will just dump it there. Against pollutions, water, all these pollutions, water, air, soil, all these pollutions. Even when these e-materials are landfilled, because this is what people are doing in a lot. I will just show on small slides here. Actually, this is just like you can see there's a pit where all this waste can be dumped. So just go on dumping. Now, what about the land get polluted? And if there is any well near to it, any groundwater related to it, and these are not degradable. So many gases will come out because anyway things or other things is going to react it. So toxic gases will be released. It gets mixed with land, it gets mixed with water, and underground water will get polluted. Under land is also polluted. Even already there is some gases available. Even suppose if there is any methane or any gases which is there, they also get contaminated. The actual nature of the land, water gets degraded, there gets changed. That's the change in the ecosystems. And those places may not be good for, or nearby places may not be good for agriculture purpose also. But mostly we are doing this landfill. Then the final thing is recycling. So recycling, okay, I'm putting one word recycling, but we can have this reuse or recycle. So how we do? Okay, I have a computer. It's gets slides over. Okay, takes part. Why not we can use it in another computers or monitors? That is actually called refurbished. Okay, why not we can recycle? We are doing this papers. Just go and put papers in waste paper stores. They will just take go there, recycle, and most of our newspapers, daily papers are recycled papers. Okay, so this is one way where we can reduce the amount of e-waste, but still it is not a good practice. We have been thinking, okay, recycling is important or not. But even during recycling, this we have sort of incineration, some burning. We have to do some sort of refurbishments. We have to remove it. The chemicals that is involved, the people has to involve it. We have to take it. We have to transport it. So all these three things: recycling, landfilling, and incinerations, by some means, they are hazardous to the environment. And this is an alarming statement which you can see in most of the United Nations reports. Of the like China, plenty of electronics that is from other countries, and many countries and sources to get polluted. They coming. With me?
சார் உங்க ஸ்கிரீன் வரல, சிக்னல் ரொம்ப வீக்கா இருக்குன்னு நினைக்கிறேன். உங்க ஸ்கிரீன் வரல.
Try வருது. Me?
சார் ஆடியோ கூட ஒண்ணுமே கேட்கல சார்.
விட்டு விட்டு தான் சார்.
ஸ்கிரீனும் வரல, ஆடியோவும் கேட்கல. இப்போ
கேக்குதுங்களா சார்? இப்போ
உங்க குரல் மட்டும் கேக்குது. கேக்குதுங்களான்னு கேட்டது. மேபி
ஓகே சார். ஸ்கிரீன் தெரியுது.
ஸ்கிரீன் தெரியுதா சார்?
சார் தெரியுது சார். ஃபுல் ஸ்கிரீன் போட்டுருங்க. ஓகே சார்.
ஃபுல் ஸ்கிரீன் தெரியுதா சார்?
தெரியுது சார். ஓகே.
Okay, sir. So sorry for the interruptions. Again, this is our technical fault. So India is importing lot of electronic waste. Okay. So it is again an alarming situations. So how to manage this sort of things? So there are many ways by which we can do. So since we are talking about this electronic parts, there is one improved way. We call it as green electronics. So actually what is the green electronics is, it is the usage of materials, lead-free, eco-friendly electronic equipments, and whatever the materials or devices that we manufacture should be biodegradable, and it should not harm the environment, so that it will lead to sustainable futures. So this is what we called green electronics. So there are green technology or green devices, all are there. But when you say this word green electronics, we have to think of materials, ingredients, which are very less harmful to the environment. Probably they are mostly biodegradable. You can see in this one picture, which I have just taken one from research papers. All these leaves, we can see some sort of things. Actually, this sort of researches are going on. Why this picture I have shown here is, it is a plant. So plant is normally a biodegradable. So nature has given a lot of resources. Use materials from the plants, take materials from the plants, use it, construct devices, construct transistor devices, bigger ones, so that they are very less harmful to the society, less harmful to the environment, and they are biodegradable. So I was telling about this basics, green electronics, it should not be very harmful. So there is two terms which is mostly used in this green electronics by most of the countries. This WEE, waste, electrical and electronic equipments, reduction of harmful substances. So in the manufacture of all these electronic devices, electronic equipments, or even electrical parts, environmentally harmful materials should not be used. But practically it is not possible. We can reduce the amount to a greater extent. And we should go for eco-efficient manufacturing process and power consumptions. When you talk about power consumption, it is one of the very important thing in this VLSI field. Like any devices has to consume low power. When we talk about this mobile phones, what we take, my mobile phone battery should long. This is actually, it should consume less power, less area, and it should not harm. So this is one of the major point in anywhere consumption of power. Then finally the devices what we are going to manufacture should be fully recyclable and no hazardous waste is left out. So that by applying this green electronic concept, new electronic applications enable sustainable and eco-friendly solutions can be obtained both from the industrial side and customer side. So if you want to go with this green electronic concepts, because many researchers are there, first we have to start. We have to think about eco designs. We have to make some steps. So briefly, I have listed out 3 things. First one is we are telling about non-biodegradable, degradable, there is some hazard. So there should be some measurable unit. Okay, when we talk about sound, audible sound, this level should not go above this. When we talk about air pollution, so if it is over ppm, it is level 1, level 2, like that. So we have some measurements. So that sort of measurements first has to be kept. This is what you called measurable environmental targets for each and every type. It may be differing from different countries, but European Union and American Unions or United States, United Nations, they have all set up already. They have kept some measurable targets. Even in Indian air pollution control, but also they are having some targets. But for the manufacture and the usage of these electronic devices, there should be some targets. The next one is every now and then there should be some design reviews. So when there are any devices being developed, whether in research state or in applications, it has to be reviewed. Why not? That can be reviewed during the development phase itself. So any researchers, when it is any product, when it is being designed, so there are a lot of reviews that is going on during the development phase itself. So if anything is going wrong, or if we are going out of the final product, we should come back, we should review it again and again. And many metrics has to be set so that environmental performance of the products can be measured either during the development, okay, in paper when you are writing, but experimentally, what are the metrics that has to be measured? So these 3 things has to be taken care. So if you are using all these 3 steps, and we have to think about these things also. The material usages can be greatly reduced. Now, if you see the actual size of previous monitors, CRT monitors, we can see the sizes. And what about the plastic materials involved in it? So many PCBs, circuits, wires. Now, if you take any laptops or a normal LED monitor, LCD monitors, we can see plenty of materials has been reduced. So not only the materials has been reduced, its weight has been reduced. Its area has been reduced. So like this, we can go for by usage of less materials, equipment weight can be minimized, and we have to choose the materials. That is what more important. We have to specify the materials for any construction of any electronic devices. And what are the materials that is available? So there are so many researchers, chemistry persons are doing. That's why nowadays we are telling no engineering or no science should not be left out. All are integrated. And we have to see what are the resources that is available. As I told earlier, nature has given a lot of things. We have to go for alternate resources so that we can achieve our actual target. Okay, we should not degrade our environment. And during the production, actually the very final point I have told, it is not only if during the production cases, but also it is applicable during the usages. Waste materials that we are getting during production has to be minimized. Not only with the respect to materials, this power consumptions, because power consumption is also important. When more power is used, actually we require more power. So more power production is required. Then you have to go for there's a hydroelectric power, thermal power, etc. So all are interrelated. So that's why I'm use these slides. We have to emphasize on the power reductions. So normally when we take any mobile phones, when we are not using it, automatically it goes for standby mode. So those sort of things has to be implemented. And actually that's a concepts in electronics, low power reductions. There are many techniques like architectural designs, algorithmic designs and all. So in that things, all these things comes like this. The second one, like switch off the parts when they are not used in time. That's why I told you an example in a mobile phone or even in our laptops. When we are not using it, it goes to idle state and some parts will be switched off. We can switch on afterwards, or when you are using any app, it will automatically switch on. Then this clock frequencies, actually here this clock frequency is the speed at which any electronic devices is operating. So what's the processor that is involved in that? What's the microcontrollers involved in that? Now we talk about this i5, i7 and all. So gigahertz ranges are used. When we are going for a very high frequencies, again, we have to come back for power consumptions, area and all. So depending upon our requirement, we have to go for speed. And each and every component which is there in the electronics, whether it's a resistors, capacitor, etc., all will consume power. And usually in electronics, there's a term called clock is a power hungry circuit. It will eat up a lot of power. That's why it will become heated. So even when you see in our laptops or there's a lot of heat. We have to go for law of conservation of energy. Energy can either be created or be destroyed. It has to be converted from one form to another form. So electrical energy is converted into heat energy. So that sort of power consumptions has to be reduced. And for that also, we have to go for designing the power supplies, high efficiency power supplies. So we cannot ignore anything. All are interrelated. So whatever the things which I just told here, you can see in the slides, all are interrelated. Power consumption has to be lessened. The operating temperatures of each and every devices has to be lowered. And what people always go for is longer life of any product. But as I told you, nowadays you cannot expect any product to be of longer life. In any laptops or computers or TV sets where we are getting it, they will tell, okay, this will work only for 2 years or 3 years or 1 year, that's all. So this has become a problem. But as a customer point of view, we always we need any product to work for a longer time. Even when you talk about any mobile phones, we are seeing one model, the other model is changing. Nowadays, generations, okay, I have used this mobile phone for 2 months. Now a new model has come. Just throw it out, get a new model. And the mobile phone manufacturers, they are also coming up with new models. Now, what about the old models? What about the old phones? All are electronic waste. Okay, so I think I have told this also earlier. So to minimize waste, we have to recycle the 3 things which I have told earlier: incinerations, landfilling, recycling. So by keeping this in mind, recycling, what are the things you have to do? First thing, of course, any devices, any materials, starting materials which you are developing, we have to think of whether it can be degraded, biodegraded, and anything has to be easily dismantled. Even when you are recycling it, some clean materials, we can obtain it, and they can be treated easily so that it can be reused properly. And different materials, suppose if I'm take for example, even for a dinner, if I'm not getting chapati, I'm going for dosa, like that. Some materials we have to go for alternative materials for manufacturing. So many polymers, biodegradable polymers are available. It is not one polymer. It's, of course, we have to mix it with many chemicals. So many polymer materials are nowadays available. We have to do researches so that lot of electronic devices, electronic components. So I'm repeating it, electronic components, because they are the fundamentals. any plastic boards. Printed circuit board is actually a plastic boards, which it is mostly not degradable. So we can use of any polymer materials, cellulose materials, paper materials, etc. So that after using it, we can easily dispose it. After some days, it is biodegradable. And mostly in our electronics, the silver, tin, copper, of course, lead, all these materials are in our ICs, integrated circuits, in our PCBs, you can see many tracks. Gold is used. So you know what is the cost of a gold now. So when we are using gold there, it is a good conductor of electricities. Okay, so right from the inception of all these integrated circuits, gold is used. Many precious materials are used. We have to, because they are very good conductor of electricities. When we want very high-speed devices, we need a much faster conduction, the flow of electrons. So this is what we call the current. Current is the flow of electrons. So we have to go for alternate ones so that we can increase the speed, power consumption can be lessened, and of course, this green electronics, the main concept is it should not harm the environment and it should be biodegradable. Go for modern production equipments so that this kind of materials can be used. I will just tell one or two things, especially I told in the beginning, this lead. Wherever you see soldering, whenever you go for any service persons, any service technicians, they'll be having one soldering iron rod. Then he will be having some small paste, we call it as a soldering paste, and one more small pieces like a wire. It is a soldering iron, we call. So it is actually a combination of tin and lead. Without this lead, you will not find any of these PCBs. So the electronic equipments, if you want to go for soldering, it is just like a small welding. Without lead and tin combination, you cannot find it. So there are so many disadvantages of using this lead. Okay, we have to avoid the usage of lead. We cannot 100% avoid it. We have to minimize it. We have to go for other materials. So many researchers are there. Still, many companies are have already done some researches. The amount of lead that is involved in soldering has been lessened. Now, actually, when we are talking all these things, why we have to go for green electronics? What is the driving drivers or motivators apart from clean and green environment? So in these slides, you can see that's a potential competitive advantages. So now this is a competitive world. Every manufacturers, they can have a potential competitives. Even the government can ask companies, okay, you come with new products. And when this is the case, the company will think of, okay, I have to go in this, I have to go for a growth. And there is also a responsibility from both all the citizens. A corporate should also have a social responsibilities. And what is the customer requirement? I told you, any customer wants any devices to last long, but nowadays this is not possible. And when we talk about biodegradable, you cannot expect anything to be working for a long time. So newer technologies there, newer markets will come. Of course, that's a green images will come. There's a product development, and more important, new job opportunities can be given. Okay. Few materials which is present in most of our electronic devices, whether it is PCBs, printed circuit boards, the traces, our computer monitors, computer screens, whatever may be the electronic devices, which I told you, electronic devices, home appliances, etc. Few electronic waste you can see here. Actually, these are the materials which are present, like americium, antimony, beryllium. I will just take this lead case here. Lead, mostly it is used in solder, lead acid in batteries. So we are using batteries. lead batteries, cadmium batteries, CRT monitor glasses. So as you can see here, these are different chemicals or materials which are used. Where they are used, you can see on the right hand side. As such, it is not going to do any harm, but when they are disposed or when there's any problem, now that's an issue. Just one or two things I will highlight here, like this PCBs contains mostly polychlorinated biphenyls. So what is their effect on human beings? Any reproduction defects, especially birds of prey. You might have seen in this 2.0 film also, birds gets affected. Lead, since I am talking more about lead, so if you just go with the Google it, you can see lot of research papers, lot of things. They will be talking more about lead-free materials, lead-free soldering, lead-free devices. So this lead will have effect, like they will affect the central nervous system, kidneys, directly or indirectly. So lead poisoning we are hearing, mercury poisoning we are hearing it. So all of them are potentially harmful substances. They will have a harmful effect on human beings, living beings, land. What we have to do is we have to lessen the usage of all these materials. So whatever the raw materials that we are searching, we are using for the manufacture of all these devices, PCBs, etc., cables, we have to see that they can be biodegradable. Why all these things has happened? As I told at the very beginning, it is because the development in the semiconductors, electronics fields. So after that, all has got interrelated. Only if I have a very good systems, I will go for a very software. So I have to develop a software. So only by having a new set of softwares, I can use it for development of new sort of devices, whether it may be a car model or a fan model, whatever may be. So all are interrelated. So lead. Every time we talk about lead, it is one of the mostly and widely used harmful substance in all our electronic devices. Either we do manually soldering, and there are plenty of, you can see this motherboards or any PCB boards or any television boards, all are soldered, all are machine soldered. When you take any LED TVs, it will just, if you just open it, you have some PCBs. If there's any fault, the technicians will just say, okay, you have to remove this board, you replace it. But think of earlier, some 10 years, 20 years, it will be a CRT TVs. If any problem occurs, the service person will come. You can just check it with this multimeters. You just pinpoint it. Okay, this particular component is gone. Okay, we will replace it. He will be having this soldering rod, soldering iron. Now, if you see in your television sets or any monitors, if anything's gone, okay, remove it. We have to replace the entire thing. Of course, it is good in one sense, but what about from our customer side? So from long, it has got a long history. Why this lead has been used? It has got a low melting point, high strength for bonding. So this is one, low melting and high strength for bonding. This is one of the most important things. Still people are not leaving this lead. Otherwise, my device will go faulty in a very few days. My connections will not be there. So these two, this low melting point and high strength, are the most important things. Still people are mostly relying on lead for soldering, not only soldering, any track makings. So other properties which you can see here, like high thermal cycling, corrosion, long life. Most of the countries, most of the companies, they are still stubborn. No, we will not use this. We will not go out of this lead. If you can go at, there are many European countries, what they have done is, okay, if you prove that you have used less amount of lead in your product, we will give some taxation relaxation, monetary benefits. Okay. So a few green electronic materials, which I have listed here. I'm not going full deep because it will take much time, like biocompatible electronics. Of course, you might have seen this nowadays, OLEDs, organic light emitting diodes. So actually organic light emitting diodes, of course, it's not fully biodegradable. During class hours also, during class segments also, our students tell it is fully biodegradable, but it's not fully biodegradable. But to some extent, it has been made that it can be degraded by adding some other chemicals also. So as you can see here, like biodegradable electronics, conductors, electronics, especially this cellulose fiber-based substrates. These cellulose-based substrates and paper, shellacs, these are the recent, of course, many researchers are going for years. These are the substance which are now mostly people are trying to employ it for manufacturing of basic electronic parts. But their lifetime is very less, but they are very, very less harmful to the environment, and they are biodegradable. One such thing, our basic material is our paper. We are seeing a paper in day-to-day life in different forms, whether it's a newspapers or notebook papers. So let us use our paper by adding some biodegradable polymers, inks, so that it can be used as a substrate. So in the electronics field, in the design of ICs, we usually call something a substrate over which all the electronic devices are constructed, millions of transistors, millions of circuits. So why not we can use the paper instead of a non-biodegradable silicon? It is abundant in nature. It's a low-cost material and it is recyclable. So I have just taken one example, a paper. Use paper, develop biodegradable electronics over that. When its lifespan is gone, okay, let us put it somewhere or keep it with us. You put it in the mud or any chemicals you added, all are biodegradable. Sir, can you able to listen me?
Yes, sir.
Sorry, sir. Sorry for this technical difficulty, sir. Sir, can you able to listen me?
Yes, sir. Yes, sir.
Okay. Okay. So these 7 persons, actually they are holding something. It is not any design they have done in computer, and it is a printout and shown. Actually, this entire thing is one bigger electronic circuit, a board, and all are biodegradable. They have done it and proved it. This actually they are 10 years research work. They are scientists from Portugal countries. And here you can see one, it is just like a polythene paper. Actually, it is not polythene glass sheet. It is a biodegradable paper, and it is a bigger circuit. They have actually it is a macroscopic view. This is something like 10,000, 1 lakh times bigger views. So use paper with the different biodegradable polymers involved in it in the manufacturing of electronic devices. Okay, I think we are nearing to the end of my presentations. So electronic products which consumes less energy. So as a part of green electronics, as I told earlier, there should be a consumption of less power. So why not we can manufacture LEDs, LED lights, which consumes less power by the usage of these green electronic materials, any portable devices, non-toxic and eco-efficient products. Many biosensors are there. Many biosensors are there, which are being in a research phase. Of course, even nowadays also we are having this Indian Institute of Science in India. That's a separate divisions where they are involved in many biosensors development, especially for medical applications, which are recyclable or biodegradable. So energy solutions like we use solar cells. Even the solar cells which are shown in the picture, they have a biodegradable solar cells. Okay, use it for 2 years, 3 years, and if you put it on soil, it gets actually degraded. So environmental monitoring equipments, water sources, water tap sensors, they all can be manufactured with the help of those biodegradable materials which are shown in the earlier slides, and a few of them are available. And I will just show something. Actually, you can see here, it is by seeing we cannot tell. Actually, this is a biodegradable semiconductor developed by Stanford University researchers. This is not one circuit. If you just take our entire laptop, what are the circuits involved? So you can have it. Actually, again, it is a very macroscopic view. So plenty of researchers is going on, and some of them are implemented. But what we have to say is, as the day goes, we have to see how they are degradable. Again, these are some researchers. This is original 1 hour, 4 hours biodegradable electronics. It is original is there. After 1 hour, it has been degraded. After 4 hours, it has been degraded. I was telling about biosensors, a medical waste. Even they also electronic waste. Suppose if they are getting degraded, even 1 day, 3 days, 30 days, it will be very helpful for the environment. We can save our environment from medical e-waste. Again, these are the pictures that is taken from Stanford Research Labs. Many companies are coming up with their devices. Just 1 or 2 examples I have shown here, like Apple's new hardware structures. So they are having, you can see this is actually like a CPU monitor. Okay. Here, many electronic components are biodegradable. Likewise, Sony, they have come with some Walkman, lead-free products. So I was emphasizing more on lead because it is the most important thing which is used anywhere. So use very few percentage of lead or lead-free products. So whatever the things that we talk about green electronics for sustainable development of countries for sustainable futures, many of them are still many of the things are still in research levels. So the disadvantages, I've just pointed out 4 things, but as there is a head on the one side, you have to see the tail on the other side. Initial costs are very high. So the companies, they are not ready to invest money, the factories, because researchers they have to do. They have to go for many chemical manufacturing companies. So that is the main thing. First thing, initial cost. Second one, green products are expensive. If you take this OLEDs, nowadays we are talking about OLED TV. See what is the price of the TV and how much year it will last. When you buy that OLED TV, even the dealer or salesperson, he will not tell. He don't have any idea. Okay, he cannot give any assurity. It will go for 10 years, 12 years, because all these things are in the earlier stages. And the third one, it is very important. Whether any industries is manufacturing, government is putting, who is the final benefiter? We, the consumers, general public. Most of us don't have the knowledge of this green electronics. As I was telling earlier, if I'm getting a TV, if I goes after 1 year, the manufacturer will tell, since we have used green electronic materials, this will last only for 1 year. Whether the consumer will buy it, surely they will not buy it. So that is where we, as a general public, we lack. But it is biodegradable. If we are ready to sacrifice our environment, okay. If we are ready to save our environment, it is good. Otherwise, it is a very hectic thing. Then final thing, greenwashing. It is just like a brainwashing. It is greenwashing. Everything companies will tell. They will give advertisements. People will give advertisements. Okay, this is biodegradable. This is watermark. It is green. In fact, it is very green. It is biodegradable, but it is not so. Any product you cannot expect at this stage 100% biodegradable. It is fully green. So a few disadvantages we have talked about. So there are pros and cons. But what is the ultimate aim? Whenever we talk about green, we have to search for materials. We have to use those materials so that it is not going to harm the environment, and at last, at any point of time, it should be biodegradable, and it should not pose any harmful threat to the environment. And we have to, this is the right time. Of course, plenty of researches are going on, but still researchers, government has to come with new ideas. They have to fund many companies, any startups, if they are coming with new ideas. Even there is a new innovation competitions for green electronics from our central government also. We can give many sort of ideas so that we can save our planet. So this is what we need at the end of the day or end of the hour. Thank you. Thank you for listening, all of you. So sorry for technical interruptions from my side.
Thank you, sir. If there are any queries from participants.
So I haven't gone for much of this electronics. Everywhere it's there. But how we are going to utilize it? Some of them we are using it without knowing it.
Thank you, sir. If there is no query from participant, we can proceed with the vote of thanks. Request Chairman.
Thank you. Yeah. Thank you, Vivek, for giving us the opportunity to interact with Professor Mohammad Mian. Actually, sir is widely known for his involvement in the work for towards the green, or instructing or taking classes for the with respect to green and the eco-friendly subject. Mainly this green electronics. Initially, I thought what it is going to be taught with. Like that, I astonished. Then when we have gone through the presentation and gone through the lecture session, it was really interesting that it should be eco-friendly, and all the material which are going to be involved in the manufacture of gadgets and all these things should be biodegradable. That exact pinpointing the eco-friendly environment is the responsibility of the any manufacturing, and the government of India also should support for it. Like that, he was telling us a lot of information with respect to right from the basics. He started and he has covered up the subject in entirety. On behalf of the Institution of Engineers, Ranipet Local Center, we thank you, Dr. Mian sir, for your involved preparation and giving us the lecture in full. And I thank all the participants who joined here in this session today. And I thank the State Center, who has supported us with the Zoom platform for having this lecture session conducted successfully. Thank you very much. Thank you all, one and all. Thank you, sir.
Thank you, sir.
Thank you, sir. We'll meet in another session.